All right, recording is rolling. It's Monday, March 6th. Here is top scientist for thermal materials. So awesome job if you're on that list. I haven't handed these quizzes back yet. I'm still waiting for a few to come in. So check focus, make sure you have turned in, and if not, then see that. Think about it soon. Right, so today and tomorrow, I'm having you guys construct toothpick bridges, and we're going to test these on Wednesday. Is the plan for most of this week. So uh, you guys have a pack of toothpicks. I think it's 150 or so toothpicks in here. This is going to be your budget. You can use this in Elmer's glue, right? So this is glue. You're going to put together a toothpick bridge. Now, when you're gluing stuff together, you can glue on the paper. So I gave you guys some sheets of paper, but the paper is not one of your structural materials. So right before I test it, if you guys could tear off the paper as much as you can. If there's little tiny paper fibers get stuck to glue, that's okay, but the paper's not part of the structural materials, right? So toothpicks and glue, correct? Okay. And what are we trying to do here? Gonna have you guys span a 20 centimeter gap. You guys do have some rulers on your desks, right? You guys have rulers. So I think what I'll do when I've done in the past is taking two desks and just separate them by 20 centimeters, okay? And then you're gonna span that gap. Now, do you guys want your bridge to be exactly 20 centimeters long? No, because this is just going to fall through the hole and down to the canyon. So it's probably at least 22 centimeters, and ideally maybe close to 25 you want it to be, right? So have like a, at least a couple of centimeters to spare on each side. Right? Probably makes sense, right? Right, so give you guys some tips on this. Let's say maybe it's like a tunnel bridge and you're driving through. Back up. Right, forgot to tell you a little bit more on the mechanics. Okay, so how are we gonna test the thing? So I'm gonna load weight basically in the middle. What I'm gonna do is set this roller tape right on top of your bridge. Okay? It's 9 centimeters diameter, in case you wonder, 9 centimeters diameter, so almost half the span, uh, the gap that you're spanning, right? So 9 centimeters. Okay? I'm gonna put this right on top of your bridge, and then I'm gonna take that gray tray that you guys turn your work into. Flash this in front of me, right? So this is the gray tray you guys turn your work into. Okay? I'm gonna start stacking lab weights in it. Okay? I'm gonna see who's gonna hold the most weight. Okay, right, you guys get that? Right, so this is going on top of your bridge. It's 9 centimeters diameter. I put this on top. Okay, then I start stacking lab weights. Okay. Oh, no, this is going to be some creativity in the design. You guys can come up with a unique design. If you go with, say, like a flat top, it's probably easy to balance all those objects. But if you go with like a pitch top that comes to a single line like I did in this picture, then I'll just balance it myself. So just to cancel out the torques. Okay. So that's okay. You can go with design like this. Okay. Now let's go back to if you're driving through a tunnel bridge. Okay? And you're looking at this cross section right here. It's cross section. Okay? Let me open it up and give you guys a couple possibilities. So the one on the left versus the one on the right. Okay? Now you guys know of course the forces coming from the top. You're going to start loading weight from the top. Okay? Now one of these two cross sections is a much stronger design than the other. And of course, the weaker one's going to break first. So which one of these would be stronger? Let me see a show of hands what you guys are thinking. You have to remember way back to last semester, there was a lab we did that would give away the answer, sort of. So show of hands, how many guys think the one on the left is the stronger design? How many think that? One on the left. Who thinks the one on the right is the stronger design? There's my winners right there. There's my winners. Oh yeah, more go up. More winners. All right. Yes. So if you have your materials oriented more vertically, then it will be able to carry more weight. So do you guys remember back last semester, I had you guys do those 10 mini labs with the spring scales? And one of the setups, I had you guys hang a spring scale vertically, put a lab weight down here, and then take a couple of spring scales and pull them out into like a Y shape, right? Like they started vertical. So if the weight was 10 newtons, like this guy weighs 10 newtons, then when these two were exactly vertical, remember it was like 5 and 5, 5 newtons, 5 newtons. Okay? And the more you spread it out, remember the weight would increase, or the force rating, right? The weight's not changing, the weight's still 10 newtons, but the force rating would go up. And if it was exactly 120 degrees, in fact, these were also 10 newtons each. It'd be 10, 10, and 10 newtons, right? And if you make it close to a T, then the weight, so the force rating in each of these kept going up. And you can never make a perfect T, right? You guys remember that? And the here, let's do force analysis on this thing. So we got force, force, force. Okay. What we did last semester is we would break these two forces down into components. Okay. Okay. And you see that some of the forces in each direction has to go to zero. So this horizontal zero out, right and left zero out. Okay. And then that vertical portion and that vertical portion have to zero out with this vertical portion. So it might be like 10 newtons down, and then each of these components would be 5. So 5 and 5 up, right? Okay, you guys get it? Okay. Ooh, see some right triangles going on here. Sure. Okay, you guys remember that? Okay. Now, the bridge is the same concept, but it's compression instead of tension. Okay. So let's take suppose I stack on a 10 Newton force for each one of these 10 Newtons and 10 Newtons. Okay. The one where it's pretty close to vertical, do you think the force of compression is now going to split pretty close to 5 Newtons and 5 Newtons? Okay. I think so. It'd probably be pretty close to 5 and 5. Okay. But the one that's horizontal, each vertical component has to be 5. So now overall, it's going to be more than 5. It might be like 10 Newtons compression, 10 Newtons compression. And if the toothpick breaks at 10 Newtons, then this one's on the verge of breaking, and this one could still hold like almost twice the weight. So this one's much stronger design. Take a step. Similar idea to if you have a like a 2x4 piece of lumber. Here, sketch that real fast. Okay. How should you orient this lumber to maximize the strength? Should you orient that way or that way? Suppose it's going to carry a huge vertical load, kind of like the bridges that you guys are designing. Okay. Which is the stronger orientation of that 2x4? The one on the right, for the same reason. It's a stronger orientation. It's carrying like a vertical load, right? Is that? Okay. And last piece of advice to give you guys is usually every year I've done this many years. I know it's going to be a bit challenging, but students always make this work in the end. Is there's usually a group every year that wants to make a beaver dam where they just like throw a bunch of toothpicks in like some kind of a pile or maybe straighten them out and just like take a bunch of glue and those never work. So I see it every year. Like somebody said, "Hey, I got an idea. Let's do beaver dam," and they'd say, "Oh, well, maybe we should like throw it in the fridge or something." That didn't work either. So just letting you guys know ahead of time. Seen that. So yeah. Okay, so so come up with a design with your teammates. You guys make one bridge per team. Put everything together on paper. It's gonna be today and tomorrow. You guys are gluing it together, and we'll test Wednesday. Just take the paper off as well as you can, and then remember taking this roll of tape, 9 centimeters diameter, stacking this in the middle, put the grade trap on top, and then start stacking these weights on top of it.